Hello everyone, in this video I will show you how you can create a generic API which can fetch data from any of these MongoDB collections and databases. So here I have some sample database and also some collections and I have this React app where I am fetching all the collection and databases information and all of this is happening with a single set of CRUD APIs which we are going to build. So this is all dynamic, like if you want to change the title of this table and also column headers, everything is dynamic. And also we have pagination, sorting, filtering and search. We will build all of this one by one and see how we can utilize one single set of CRUD endpoints to do all of this. So let's go to our editor. So let's do npm init. Just do continue to create our npm project. Now we will just install the dependencies. So for this project I will be using Express server 5. Okay, now we are ready to create our index.js. So here in my editor I have some basic setup ready. So this is just a node server where I have the basic dependencies configured. So first thing that we are going to do is to connect to our MongoDB database. For that you have to create a .env file, and there you can specify your Mongo connection strings. So first let's create a global variable which will hold our Mongo client instance, which will be using to do all the database operations and do all the database calls basically. So just instantiating a new Mongo client and then connect and initialize our client. Yeah, if there is some error at this point, then we will just console log it. And now for first endpoint we will do for the filtering operation. So here I am using app.post so that we can have the filters definition in a request body, and then we will take the database and collection from the path parameter from the user. Okay, so in this fetch endpoint, whatever operations we will be performing to get the data, that we will do utilize aggregation pipeline. So let's create the DB instance and get our initialize an empty array. So in this application, when you fetch data, the filter, sort, pagination, these are optional. So you can make a request like this where we have our database name and collection dynamically specified in the query. Now in this pipeline, the first stage that we are going to have is search, $search. So $search basically perform a full text of search operation. Here you can see it. For example, we will just check if this search query is there or not. If it is there, so then we will take the search text from the value. We will take this value and create a aggregation stage like this, where we have dollar search, and in the query we are specifying our search text, and we also passing this path, and we have this wildcard star, since we want to search across the document. Even if some text is there that is inside some nested document, it will also get those in our response. So here, for the full text search to work, we have to go to MongoDB portal and create a search index. So here you can go to the Atlas search tab and create a search index for whatever collection you want to enable full text search. This will take some time, so let's continue. So our request body will look like this, where we are having this field operator and value, and we can specify multiple filters at once. So in our data grid, we have different type of data, like this underscore id is a integer, and then this column is a string, and for these different data types we have different filter operators. So for numeric data we have equals to, not equals to, and so on. For string type data, this is dynamically getting this operators like contains, equals, starts with. So to accommodate that, we have to, so here to handle all of those conditions, we will consider this, that there will be string operators like contains, not contains, and this, and we have these numeric operators. For boolean we will only have is. So in case of boolean, the value will be either true or false, but in the data grid we are all going to get this value in a string format, so we will parse that as well. And based on the request body, we have to generate a MongoDB dollar match stage. So our MongoDB dollar match stage will look like this. Here we have the dollar match, and inside we have and so that will consider all of these filters. So if for a document, if all of these filters are satisfying, filter conditions are satisfying, then we are only going to get those data in our response. So for to generate or convert request body to this, we have to have this array first. So initializing an empty array, then in the request body we will be iterating through the request body, and then generate a object like this. So to generate a object like this, we will just initialize the empty query object, and using a switch case, we will check what type of operator it is, and if for example if the operator is greater than, then we have to use $gt and so on. So for that I'm using a switch case. Then the case is, if we are having equals to, then we don't have to pass any dollar function like this, it will be just the value, and we are converting it to a number, so the value will be in string. But now with this number class, we can just convert it to a number that can be a floating point number, or it can be a integer. And similarly we have other numeric operators. So for not equals to, we have $ne, and for less than we have LT, and so on. Now for string operator, we have to use regex. So here I am checking if this value is there or not in our field, and it can be this value. After and before this value there can be any number of characters. So to indicate that I am using dot star. You can find out more about regex online. Similarly, we have not contain, starts with, ends with, and other operators. So in case of boolean operator, we have is, and again we have to convert our data, our value to a uh, appropriate type. So here I am using this condition to check whether the value is true or not. Based on that, it will return a boolean value. And finally, we will be throwing invalid operator error if there is any other type of operator specified. Okay, now this much is done, so we can now insert our okay, so here we have created this object. Now we have to insert this to our array. So for that we will just call push. And next, as I said, this filters, sort, and other query operations, these are optional. So we will have to check if our request body's length is greater than 0 or not. If it's greater than 0, then there is some filters, and based on that we will push this pipeline stage. Now for sorting, let's look how our request URL will look like. So for sorting, our request URL will contain this type of pattern where first we have specified the column, sort column, and then with after a space we are specifying the sort order. So again we will take the data from our query and see, like we will be splitting this string. We will be splitting this string with a space delimiter, and for here this split will give us a list, and from this list first element will have column, and then second will have so for sort order, basically MongoDB expects a number. So in case of ascending it will be number 1, and for descending it will be -1. So based on that I am going to check what is the value of the second what is the value of the second sort parameter. If it is ASC, that means 1, and otherwise -1 for descending. And let's push this to our aggregation pipeline. So here I am specifying this variable sort column in a bracket, since this is a key in position, and we want to extract the value of this variable. So we needed to use this destructuring pattern. Okay, so now for pagination we will consider two parameters. One is page and page size. So here the page is going to start from 0, just like any array index starts with 0. So we'll take that, and again these are in query parameters, so that means it will be in a string format. We have to parse it into an integer, and we can calculate our how many documents to skip, and then we can have so in here we want to make one database call to get the total number of documents as well. Since we are implementing pagination, so we have to use facet. In the facet we have data, there we can pass our skip and page size. Then in the count we will count how many records are there in our data array. So after this is done, we can just make a aggregate call to Mongo database, and there From there we will be getting a response like this, where I have an object like this and that contains our data, and also it contains count. So in this we don't want to, this is kind of a complicated format. We want to make it simplified, so we will generate a object. And here if the data is empty, data array is empty, then the count array is also going to be empty, so we will not be able to access the total number of records. So for that we have to handle it here. So I am saying that if the count length is greater than 0, that means we can access the total field. So we are accessing it, otherwise it will be 0. And now we are ready to send it to front end. Okay, so with that our filter operation is done. So here we are having this table. This table is also dynamic. That means whatever fields this table is going to have, those are coming from MongoDB. So if you open Compass, here I have some sample data, and here I have a validation tab. There I have mentioned the schema. So this products collection contains these properties. Underscore id, name is available, price, and created at. And also I can specify some validation rules, like the name must contain at least 4 characters, and we also specify what are the required fields. So this schema, this JSON schema is needed to generate the table in the UI. So we will create an endpoint to get this data. We will use this type of URL pattern where we have the schema. That means we want to get the schema of this collection and from this database. So again I'm creating a DB instance, and so here we can call list collections and pass the collection name as a filter to get the collection details. And in the collection details we will have our options, and inside option we have the validation, which we can send it to the front end. Now we can do the insert operation. For insert operations I am also going to use app.post, and here I am using this keyword insert to specify that we want to perform an insertion operation. Again I am going to take the database and collection from the path, and here is how our request body will look like. Here we have the name created at, which is a date field, and we have the price. So in this case you can see there is a date field, but this date field we are passing it as a string. So we have to convert this string format to a JavaScript date object before inserting it. So here you can see we have specified that the created at should be a date field. The JSON type should be a date, and if you pass a string, then it will throw an validation error. So to do this, we will again get the collection details by calling list collections, and this time we will get the properties of the JSON schema. Iterate through the request body and see if any of the properties JSON type is date or not. If yes, then we will call new date with this string date. And after this is done, we are good to call insert one to insert this document, and then we will just return the response. Okay, so now we are ready to do our update operation. So in this case I will use app.put, and I will get another path parameter which is id. So this will be the id which we want to update. Here we are doing the same procedure to convert any of the date strings to a date object, and this time we will call update one with the id in the first parameter, and we will use our dollar set to perform an update operation. Now we are ready to do the delete operation. For that, again I am going to take the id from the path parameter, and this time I am using app.delete, calling delete one to perform the action. So here we have written a lot of endpoints. Now any of these endpoints can throw any error, and to handle that we have to create a exception handling middleware. So currently the procedure I am going to do, that is going to be supported only in Express 5.0.0 beta. So let's see how to create a custom middleware. So here I will have just error object where we have the status and the message, and then we will send it to the front end. Here one thing we have to consider is whenever there is a validation error, MongoDB throws a error with the code 1 to 1. So first we will check that if there is in this error if there is any 1 to 1 code. So if the error.code equals to 1 to 1, then it will be a bad request. So we are setting the status as 400, and we will also going to provide the error details, whatever validation details we have. And then there is one more endpoint we want to create to construct our UI. So here you see we have our database and collections listed. We have to get this data. To do this, let's see how we can get the database and collection. So our response will look like this. Here I have an object containing our database, which is a list, and that contains our collections. For that I am just going to use the root of our API endpoint, calling the admin.list the databases to get the database info. So this database info we can iterate through the databases, and then here we are going to ignore the local and admin database, because these databases are something that gets generated automatically when you create a cluster. And then again this time again I'm calling the list collection, but in our filter object that is empty, because we want to get a list of collections this time, and we only want the name. And this time instead of calling next, I'm calling to array, since this is going to be an array instead of an object. So this in the result we will just push the database name and collections. This collection is actually an array of object. From that array of the object we only want the collection name, so that's why we are using this map. And then we are ready to return it to the front end. So with that our API is done, and we will now test it one by one. So to run this, first open up the terminal and call node index.js. Now here we'll use Postman to test our endpoints. So this was the last endpoint we created, where we want to get our databases and collections from our MongoDB cluster. So this is how we are getting the data. And for schema as well, we can just have our database name here and collection name, and then we can call this endpoint to get the schema. Here you can see we are getting the exact same thing that we saw in our MongoDB compass, where we have specified the collection title as a product column, a product table. Then we have our required fields and all other validation rules and properties. So since this is a dynamic API, so we can just change our database name like so. To get the data from different collection. So this is what we have in our company's collection. Now let's look at the create endpoint. So for creating something in our product schema, there is some rules that we have to follow. Let's so here I have specified that names max and min length is specified here. So we will specify or use some name that is beyond this length. So if I type, let's say, something like this, it is throwing a 400 bad request error. We have some validation failed. So it says that like whatever we have mentioned in our description, um, whatever mentioned in our description, it is going to give us that error. And in the details section we can see that we have specified min length as 4, but we have sent a which is less than this min length. And the same for the price, we have a minimum operator, and it is considered value is this, which is less than this value. So now one thing here in our schema, we have also mentioned that additional property is false. That means we can't put any other properties that are not specified in our schema. So this time the operator name is additional properties, which we have mentioned false, but provided one more additional properties, which is not correct. Now after all the validation rules are satisfied, it is successfully inserted one record, which we will be reading next. So for reading, we can you can see that we are trying to read from this collection, and we have the sort. We want to sort the data in the ascending order of price, and let's change this little bit. So here we can also specify that we want to search using this keyword. So based on these parameters and based on this filter, we are getting only one record where we have this keyword. Now if we remove it, we can see that the data is we have this data where the price is in ascending order and the price is always greater than 100. Similarly, we can let's change this, add another filter here. So now we are getting the data that we just inserted. We will update it. So for update also we will have the validation errors checks. If I try to update it with this data, it is giving us a validation error that the price is not satisfying the schema rules. So I can we will change this data. So here we have successfully modified one document, which we can verify again by calling the read. So here you can see our data is now modified successfully. And similarly we can just call this delete endpoint to delete our data. So after that we can see that there is the data is deleted. We don't have any data with this ID. So here let's say you want to change the title of your column or this title, then we can also just do some modification in our schema directly in the compass. In the movies, let's add something called title here. And also we will change the, we can add a title in this property. So let's add a title. Update this. If we reload here, so now you can see the title is changed to movies table, and we have the column is also updated. So everything is dynamically controlled. So this is all for this video, and thank you for watching.